We're going to look at a method for simplifying square roots that I call free the prisoners. When we simplify square roots, we're going to think of the square root symbol as a jail. Our goal is to free as many prisoners from jail as we can. In order to free a prisoner, the prisoner must have an identical twin. And when the prisoner escapes, the twin disappears. We're going to look at this in general, and then we'll do some examples. The first thing we do is find the prime factorization of whatever number is in jail. We're going to split it apart. Next, we're going to circle all the pairs, all of the identical twins. So here we have 2 guys, 2 girls. Next, we're going to move the pairs. We free a prisoner by moving them outside of the jail, and the twin disappears. So here, the guy with the barbells, he's already been outside the jail. He's waiting for his friends. The girls, one comes out of jail, the twin is disappeared. Now the guy, one out of jail, the other disappears. Then we have this guy here with his hands on his hips that didn't have a twin, so he has to stay in jail. To finish up, any prisoner without an identical twin has to stay in jail. Any prisoners that are staying in jail get multiplied together. Think about it like they're going to huddle up and complain that they had to stay. And anybody that's been freed is also going to multiply together. They're going to get together and celebrate that they're out, right? Let's look at a couple of examples. The square root of 24. First, we need to find the prime factorization. So 4 times 6, but we can go further. 2 times 2 times 2 times 3. Next, we're going to circle our pairs. We have a pair of 2s. Now, one of the 2s comes out of jail, the other one disappears, and the 2 and the 3 have to stay in jail because they don't have twins. And then we multiply together their finish up 2 root 6. 3 square roots of 180. First, prime factorization. So my 3 stays out front, and I have 18 times 10. I can keep going, and then even further. So I have 3 square roots of 2 times 3 times 3 times 2 times 5. I found my prime factorization. Next is circling the pairs. I have a pair of 2s and a pair of 3s. Now, the 3 out front stays out front. For my pair of 2s, one comes out, the other disappears. For my pair of 3s, one comes out, the other disappears, and my 5 stays in. And then I'm going to simplify it a little bit, put it all together, 18 root 5. Is there an easier way? There is an easier way, or maybe it's a little simpler if you can get perfect squares instead of factoring all the way to the prime factorization. For example, the square root of 48 is 16 times 3. 16 is a perfect square. The square root of 16 is 4. And then the 3 stays in. Think about it. If we were to break 16 down, we would have 4 times 4 times 3, right? And so we would have a pair of 4s. One would come out, the other would disappear. So this just kind of alleviates a step, or 2, depending on how big your number is. 5 square roots of 250. We could break that into 25 times 10, and 25 is a perfect square. 10 does break down to 2 times 5, but it doesn't have any perfect squares in it. There's no pairs in 2 times 5, right? So I can leave that together, pull my 5 out, and then simplify. What about other roots? This is the cubed root of 108. So to do this, instead of needing twins, I would need triplets or a set of 3 to get out of jail. Looking at it as an example, I would first find the prime factorization. So I have 2 times 54. We keep going until we get it as small as it can be. Here 2 times 2 times 3 times 3 times 3. And since we're doing a cubed root, I need a set of 3. Now, one of my 3's comes out front, the other 2 disappear, and my 2's have to stay in because they need 3 to get out. So 3 cubed roots of 4. The fourth root of 64. Well, if for the square root we needed 2 and the cubed root we need 3, now we need a set of 4 to get out, and 3 will disappear. So fourth root of 64, we're going to break it down. 8 times 8, we're going to keep going and keep going until we have it as simple as we can get it. 2 times 2 times 2 times 2 times 2 times 2, right? Now again it's the fourth root, so I need a set of 4. One of those 2's will come out, the other 3 disappear. The remaining 2's have to stay in because they don't have 2 more to get one of them out, right? And then put it together. I hope you found this helpful. Have a great day.